All right, so we're going to start off this week looking at section 3.3. The material we look at this week is all connected, so it's a good kind of progression of stuff. It's all about long division. We're going to do it in 3.3. We'll do long division. 3.4 is a different kind of division, and then 3.5 we're going to do more with the division. So all the sections kind of build this week. All right, so just a reminder of what a root or a zero is. Okay, a root or a zero is a number that you can plug into an equation, and when you plug it in, you get 0. So if I had something like, and I set that equal to 0, and I solve it, that would be the root. What would you get if you solve for x there? Yeah, 3. So there's two things you can say about 3. You can say, since 3 is a root, when you plug it in, you will get 0. Right? So this is saying, if a number is a root, then you plug it in and you get 0. So that's reading it forwards. You can also read it backwards. That's what this means. If you can plug a number in and it comes out to 0, then that number is a root. So this is what we call an if-then statement. And because they use this phrase, you can read it forwards and backwards, and it's true both ways. If a number is a root, then you can plug it in and get 0. If you can plug it in and get 0, then it's a root. Not every statement that you read is always true forwards and backwards. You learn that in geometry. It's called the converse. Sometimes the converse is true, sometimes it isn't. In this case, it's true. It's a statement that's called bidirectional. It's true both ways. So we're going to use long division to figure out roots of polynomials. Let me show you how you can do it with just regular numbers first, and we're going to do the same idea with polynomials in a minute. Okay. So let's say that I want you to factor something. Okay. I want you to factor the number 12. And I'm going to tell you one of the factors, 3. Okay. So I'm giving you a hint at one of the factors. If you know 3 is a factor of 12, how could you find the other factor? Yeah? Right. If 3 is a factor, then that means 3 times something would give you 12. Well, to solve for the something, divide each side by 3, and you get 4. That's the other factor. Okay. So when you do the division, look at your quotient, and that's the other factor. Another thing that happens is when you divide by something that is a factor, notice what the remainder came out to. When you divide 12 by 3, the quotient's 4. But what's the remainder? 0. Whenever you divide by something that is a factor, you get a remainder of 0. So that's going to be an important concept. Eventually, if we can figure out a way to do division and just figure out the remainder, then we know if it comes out to 0, whatever you divided by is a factor. If you divide two things and you don't get a remainder of 0, then what you divided by isn't a factor. Okay. So you could do exactly the same thing with this. X squared plus 4x plus 3. Let's say I wanted you to factor that. You don't know how to factor it. But I give you a hint. I tell you one of the factors is x plus 1. If you don't know how to figure out the other factor, you could do division, look at your answer, and whatever your answer is, that's the other factor. So it's the same idea that we just did with numbers. So I already mentioned that to you. If you divide two things and you get a remainder of 0, then you know what you divided by is a factor. So the reason that we would want to figure factors out is because sometimes we have an equation and we have to figure out what makes it 0. If you can factor it, it's going to make figuring out the zeros easier. If you can't factor it, well, at least with quadratic, we do have another way to solve it. You can use quadratic formula. But if it's higher than a quadratic, like cubic, and you can't factor it, then you're going to be kind of stuck. Okay, so we're going to be working with a lot of problems that do factor this week. So we're going to look at how do we do that same process we just did with 12. Me telling you a number that's a factor, doing the division, and getting the other one. We're going to do that now with a polynomial. Okay, so what I'll do is I'll put, I'm going to do a problem on the right, and I'm going to show you the steps on the left. Okay. Does anybody remember doing long division with polynomials before? A little bit? Okay, so we'll go through the steps anyway. Okay, the very first step is just setting it up if it's missing any terms. So first, just to be clear, this is called the divisor. This is the dividend. If the dividend is missing any terms, you have to fill in zeros. Okay, and what do I mean by missing? Look at your highest exponent. In this case, it's 3. We need every term from an exponent of 3 down. Okay. Am I missing any terms in my dividend? Yeah.
I'm missing x squared.
Right, I'm missing the x squared term. So we're going to fill in a 0 for that. Okay, filling in a 0 is purely just a placeholder because we need a column for x squareds. So we've got x cubed. We don't have any x squareds. Minus 8x plus 3. Okay, so that's the first step. Second step, you're going to take the first term of your divisor, x, and you're going to divide that into the first term of your dividend, x cubed. Okay, so off to the side, this is what I'm doing. It's pretty safe to do scrap work on the left here, because when you do long division, all the work is going to go down to the right. It's kind of a flow of how it works. Okay, so what's x cubed divided by x? Yeah.
Would it be x cubed?
Well, if you take x cubed and divide by 1, you would get the same thing. But you can only get the same thing back if you divide by 1.
What would be x squared?
So that's going to be x squared. Okay. So put that answer up above the line. It doesn't have to be lined up with the x squared column. It's just anywhere above the line. Okay. Now, you're going to take the answer that you just got in step 2, and you're going to distribute it back out. And when we distribute it, here's where we have to put things in the correct columns. What's x squared times x? X cubed. And what's x squared times negative 3? Negative 3x squared. So notice I put the x cubes in the same column, and then I put the x squareds in the same column, in the correct column. Okay, so now you are going to subtract the columns that we just made in the last step. So the way I do that is like this. Luke, what's x cubed minus x cubed?
x cubed minus x cubed?
Yes.
0.
0. Yeah, that's gone. Okay. And then the last column we have is 0x squared minus negative 3x squared. Well, Diego, what's 0x squared minus negative 3x squared?
0x squared minus negative 3x squared. That's 0. Just negative 3x squared.
So think of it, careful, think of it as like it's just 0 minus negative 3.
So just negative 3.
So 0 minus 3 is negative 3. But this is 0 minus minus 3.
Oh, so this is 3.
3, yeah. So this is going to be 3x squared. And notice now the exponent you started with was a 3. Now it's down to a 2. Okay? And each time you do this, the exponent is going to go down. And we need to keep going until this exponent is smaller than that exponent. So we're going to go again. So now you bring down the next term, and we repeat it. We keep repeating until either everything cancels out and we don't have a remainder, or remainder 0, or this number is smaller than that number. Okay, so let's do it again. Take the first term of your dividend, which is now 3x squared, and divide it by the first term on the outside, which is x. Caleb, what's 3x squared divided by x?
3, just straight up 3x. Just regular 3x.
Yep, just 3x. Yep. So put that up the top. Now you're going to take and multiply the 3x back out to each term. So Lewis, what's 3x times x? Kara, we're not adding them. 3x plus x would be 4x, but we're multiplying them.
3x squared.
3x squared. Yep. So 3x squared. And how about Nico, what's 3x times negative 3?
3x times negative 3. Negative 9x.
Yep, negative 9x. Okay. And River, what do we do with those columns?
Subtract.
Subtract. Perfect. 3x squared minus 3x squared, that's gone. And Jack, what's negative 8x minus negative 9x?
X.
Yeah, because that's going to be negative 8 plus 9. So it's going to be x. Okay. What's the degree on this x now? 1. And what was the degree on this x that we started with? 1. We need to keep going until it's smaller. So this is the last time. Bring down the next term. And now take x and divide by x. What's x divided by x? Caleb?
1.
Yep, 1. Okay. Distribute the 1 back out. 1 times x. 1 times negative 3. And subtract your columns. X minus x is gone. And what's 3 minus minus 3? 6. And what do you think that 6 is? That's my remainder. Okay, so there's a couple ways we can write our answer. We can do quotient and remainder. So the quotient is x squared plus 3x plus 1. And the remainder is 6. Or you can write the answer the same way you learned how to do it when you do long division with numbers. If I did 13 divided by 5, what's the quotient when you divide 13 by 5? 2. And what's the remainder? 3. So you can write it that way. That's what I just did on the right. That's the same thing. Or you can always write your answer as quotient plus remainder over your original denominator. So you could write 13 divided by 5 as 2 plus the remainder was 3 and the denominator is 5. So if you divide 13 by 5, that's 2 plus 3/5, or a mixed number would be 2 3/5. So I can do the same thing here. Quotient plus my remainder over my original denominator was x minus 3. There you go. There's your answer. The nice thing about doing it this way is I can check that. I can type in the original question, and then I can type in what I got for the answer and see if they look the same. If they do, then that means I did it right. You can't do that if you type it as like the Q and the R. There's no way to put that in on the calculator. So we've got x squared plus 3x plus 1 plus, you're going to have to do this in parentheses, 6 divided by x minus 3. Okay, so that's what I got for an answer. And now let me type in what the original problem was. And let's see if our answer is equivalent to the original problem. It should be, if we did it right. We had x cubed minus 8x plus 3. I don't need to put in the 0. And then divide by x minus 3. Okay, let's do zoom 6. Okay, so here's the original problem. Looks something like that. And here's our answer to it in red. Looks identical. So that means my answer is probably right. A graph never proves it's right, but it highly suggests I did it right, because it looks identical. Any question on writing your answer either way?
I have a question about doing it.
Yeah, we're going to do one more.
At the top, how do you always divide by x?
No, it depends what's right here.
It's always so if it was 3 minus x, you would have done 3.
Well, you always want to make sure this is in descending order.
Okay.
So always put it in descending order, and then it would be, you're never going to have one that's not in descending order. That would be kind of weird for us to have one as 3 minus x, but technically that would be a different problem, because x minus 3 is not the same as 3 minus x. But yeah, you'd have to use the 3 there, but I'm not going to give you one like that.
Okay.
Yeah.
Thank you.
It's always going to be in descending order. But in this case, you're not going to be dividing by x. You're going to be dividing by that over and over. Okay, so at first it looks like it could be worse because it's longer, divisor. Right? They filled in some zeros for what we were missing, but this problem is actually going to be easier than the first one. So just because it looks like it might be worse, it actually isn't. Okay, but that would be your first step. If they hadn't filled in those zeros, we'd want to take care of that. Okay, what's the first calculation that we're going to do off to the side? We're going to have what divided by what? Yeah.
2x divided by 2x to the 4th.
2x to the 4th divided by
2x to the 4th divided by 2x to the squared.
2x squared. And what does that give you?
2x.
Well, when
So
you
wait,
divide,
I don't know.
2's are gone.
X squared.
So just x squared, yeah. Okay, multiply that back out. Gabby, what's x squared times 2x squared? 2x to the fourth. And Dylan, what about x squared times x?
X cubed.
Sorry, say it one more time.
X cubed.
X cubed, yep. And then x squared times 1. Well, what's x squared times 1?
Would it just be x squared?
Just x squared, yep. Now we've got 3 columns, and we're going to do what in each column? Subtract, yep. If the first one doesn't cancel out every time, then you made a mistake. So 2x to the fourth minus 2x to the fourth, that's gone. What's negative x cubed minus x cubed? Negative 1 minus 1.
Minus 2x cubed.
Minus 2x cubed. And 0x squared minus x squared. That's just minus x squared. Okay, so I did my subtraction. And what do I do next, even though it's technically just a placeholder? Yeah.
Bring the x down.
Yeah, bring down, what am I bringing down?
The 0x.
The 0x. It's really just 0, but we're just bringing it down to have space for the x column. Okay. All right, now off to the side. Negative 2x cubed divided by 2x squared. Okay, what's that going to give me?
Negative x.
Yep, that gives me negative x. Okay, multiply your negative x back out. So that's negative 2x cubed. What's negative x times positive x? Oh, Christian.
Okay, negative x. Or negative 2x.
So negative x times positive x is how much?
Would have been negative 2x.
No, because we're multiplying, so exponents are going to change when we multiply variables.
Oh, okay. Negative 2x squared. Or, no, not negative 2x, but negative x squared.
Negative x squared, yep. So negative x squared. And Mia, what about negative x times 1?
Would just be negative x.
Just negative x. And let's subtract all that. What's negative 2x cubed minus negative 2x cubed?
0.
Yep. Is that what you were going to say? Yep. So that's gone. What about negative x squared minus negative x squared? That,
Zero.
yep. That's also 0.
One answered so bad.
And what about 0x minus negative x? Yeah, x. And bring down your next term. Now, what's the exponent on what's on the inside? 1. That has a degree 1. What's the degree of what's on the outside? 2. I'm done. Okay. This number is now smaller than the exponent on the outside. I can't go any further. So, we read our answer. The quotient is x squared minus x. And the remainder is x minus 2. Any question on that? So notice what we divided by. What was the degree on the denominator in this problem?
Do you mind scrolling down to see what's happening?
Yeah. What was the degree on our divisor? Yep. 2. Degree was 2. What's the degree on our remainder? 1. It went down 1. We started with a degree 2 for the divisor, and the remainder was a degree 1. Let's look at this one. What was the degree on my divisor here? Degree here was a 1. What's the degree on my remainder?
0.
0. Right? There's no x at all. When there's no variable, that's a degree 0. So notice what happened again. Started with a degree 1, and the remainder was a degree 0. The remainder is always a lower degree than the divisor. That's how that works. The remainder is always a lower degree than the divisor. All right, so let's look at a theorem. Okay, and this is called the remainder theorem. If I divided by that, who cares what the numerator is? We'll just pretend I divided by x minus 5. What's the degree of x minus 5? 1. That's a degree 1. When I do this problem out, the remainder would be a degree what?
0.
Degree 0. It always has to be smaller. It always has to be smaller. So if I divided by degree 1, my remainder is going to be degree 0. And degree 0 is just a single number. Well, if you're going to do long division, and you know the remainder is going to come out to a single number, like this problem, 6. Not like this problem. That's not a single number. That has a variable. But if you're only going to get a single number, there is a quick way to find the remainder. Okay, that's called the remainder theorem. So the first thing to understand is, when does the remainder theorem work? It doesn't work all of the time. It only works if your denominator looks like this. You have to be dividing by x minus a number. If you're dividing by x minus a number, you're going to have something in the top. Who knows what it is, but you'll have some formula in the top. If you take the number that's in this box and you fill it in to the top, it will automatically give you the remainder. It won't give you the quotient, but it will give you the remainder. So take the number in the box. Okay, that's what comes after the minus sign, not the minus itself. Take what's in the box, fill that number in for the variable in the top, and you will automatically get your remainder. Our book calls that number C. Just what they call it. So plug C into function f, and there's your remainder. So let's go back to the first question and see if we can get the remainder this way. Okay. First of all, am I dividing by something that's of the form x minus a number? In the first one? Yeah. So let's look at the number that would be in the box. Okay. It's a 3. Take the number that's in the box and fill it into your numerator, or your dividend. So let's plug 3 in for all those x's. Now, would you like to?
Would it be 3 or negative 3?
Just what's after the minus, so just the 3. Okay, just what's in the box, not what's outside it. Okay, if we plug in 3, we're going to get 3 cubed minus 8 times 3 plus 3. What's 3 cubed?
9.
3 times 3 times 3?
27.
27. And 8 times 3? 24. And what's 27 minus 24? 3. And what's 3 plus 3? 6. And what did we get for a remainder when we did this problem? 6. So we got exactly the same remainder. Right? So that's a quick way to find the remainder, as long as you're dividing by x minus a number. You could not use remainder theorem on this one. That's not x minus a number. The only way to get the remainder is just to do all long division. Yeah.
Why did we put it in that? Is that just how you do it?
Why is what?
Why did we plug the 3 into the dividend? Is that just how you do it?
That's the remainder theorem.
Okay.
Yeah. Yep, so the remainder theorem says if you divide by x minus a number, you can take that number and fill it into the top, and it will give you the remainder. I can prove why that works, because that's not normally something I go into in this class.
Yeah.
Proofs are left in geometry.
In geometry? Yeah, it's not actually hard. Just take about a minute or two to show why it works, but it's just not something we do. Okay, so now let's see if we can find the remainder when we do these two problems. Now, if we were going to do long division, it's going to take a while. But to do the remainder theorem, just to get the remainder, that's going to be pretty quick. So first they want me to take f of x divided by h of x, then take f of x and divide by g of x. So two separate columns. Let's start with f of x divided by h of x. Find the remainder. First of all, does the remainder theorem apply in this problem? Yeah. Why does it apply?
Because it's x minus 3, so negative 3 because the x is 1. Like it has a degree.
Yeah, we're dividing by something that's x minus a number. So that's why it applies. And now, what number are we going to plug in, and where are we going to plug it in? Yeah?
3 into all the x's on f of x.
Right, plug 3 into all the x's in the top. And that's going to give you your remainder. So we just have to figure out what f of 3 is. Okay, so we'll do that. 3 cubed, we just did that before. And then 3 squared times 2. And then plugging in 3 there is plus 3 minus 5. What's 27 minus 18?
9.
So 9 plus 3 minus 5 comes out to 7. That's the remainder when you try to divide h of x into f of x. Now, because I got a remainder of 7, and specifically because I didn't get a remainder of 0, what does that mean about h of x? Yeah?
It's not a 0 for that problem.
It's not a what?
It's not a factor.
It's not a factor, right? H of x is not a factor of f of x. So if you were trying to factor f of x, you shouldn't be trying to use x minus 3. That doesn't work. Okay. Let's look at f of x divided by g of x. Okay. Does the remainder theorem apply here? So it has to be x minus a number or something that could be rewritten as x minus a number. Could you rewrite x plus 1 as x minus a number? Yep. X minus, yeah. So to use the remainder theorem, it always has to be x minus, and then you have to put a number in that box. Whatever number is in that box, that's the number that you're going to plug in. So yeah, we can rewrite that as x minus negative 1. So just be a little careful, okay, when you do that one. Okay, so now, just to be clear, what number am I plugging in? And where am I going to plug it in? Yeah?
-1 into all the x's and f of x.
Right, you're going to plug in the -1, because that's what you're dividing by, into the top. And the top is f of x. Okay, so let's plug in -1 and see what we get. Okay, what's -1 cubed? So -1 and -1 squared. 1 times -2 minus 2 minus 1 minus 5. -1 minus 2 gives me -3 minus 1 more and minus 5 more. -9. Okay, so that's your remainder. So if you try to divide f of x by g of x, you're going to get a remainder of -9. What does that tell you about g of x? It also is not a factor of f of x. So what is a factor? Well, we wouldn't want to just keep trying every number till we find one. Maybe the factor is like x minus 7.3. I mean, you'd never figure that one out. So there are ways to figure out what one would work. But for now, we're just testing ones they give us. Okay. Any question on that? All right. So let's try this one. If you see any directions in the book that say factor theorem, we're just going to use that theorem that I already showed you, the remainder theorem. It's pretty much the same idea. So if x plus 2 is going to be a factor of that, what do I know would happen when I do division? I should get a remainder. Yeah, I should get a remainder of 0. That's what should happen. So let's divide these. Well, we could divide them, right? That would take longer. Let's use the remainder theorem and see what the remainder would be. What number would I be plugging in for x? And if you're not sure, think of how you could rewrite x plus 2. Right, think of it as x minus -2. So we're going to plug -2 in for x in the top, and that's going to tell us what the remainder is. And we're hoping to get 0. Let's see. All right, so let's plug in -2. What's -2 cubed? -8. Okay. And Giannalise, -2 squared? So -2 squared would give us how much? 4. Yeah, and 4 times 5? 20. Good. Okay, and then plugging -2 in here. 5 times -2 gives me, or Nick?
10.
So 5 times -2 would be -10.
I just said negative.
Oh, you did? Okay, perfect. -10, yep. And then -2. All right, let's simplify that and see what happens. -8 plus 20 gives me 12. And 12 minus 10? 2. And 2 minus 2? 0. Okay, so I got a remainder of 0. What does that mean about x plus 2?
It's a factor.
It's a factor, yeah. So x plus 2 is a factor. So now, if we had to factor that, x cubed plus 5x squared plus 5x minus 2, one of your factors is x plus 2. how would you get the other one? This is like when I told you at the beginning of class, I want you to factor the number 12. 3 is a factor. So now you know one of them. How do you get the question mark? Yeah?
You divide.
Yeah, you divide. And when you do the division and finish, what would you be looking at?
The other factor. Or the remainder.
Well, the remainder would be 0. We already know that.
So quotient.
The quotient, yeah. This would be your other factor, if you had to find it. Now, to get the quotient, you need to do long division. There's no, well, for today, there's no shortcut to figuring out the quotient. In this particular case, tomorrow, there will be. In the case that we did for this problem, there would not be. Any questions on how we showed the remainder here was 0? Okay. So let's look at a few different statements and then just about that. So if you have a number that you could plug in and get 0, we call that number a 0. What's another name for that number besides a 0? A root. Yep. So that's equivalent. It also means something graphically. Like if you were to graph the equation on your calculator, how would the roots show up on the picture? They would be what? Yep. Yep, they would all be x-intercepts. So saying that something is a solution to the equation when you set it equal to 0, saying that it's a root, saying that it's a 0, saying that it's an x-intercept. All 4 of those things mean the same thing. But this one is very important. If you know a number is a root, then you know a factor automatically. Think of it like this. If I tell you 3 and -4 are roots to a problem I'm thinking of in my head, you automatically know the factors. If 3 is a root, what's a factor you could give me, linear factor, that you could plug 3 into for x and make it come out to 0?
Could you repeat that, please?
So what would be a factor you could write down that you could plug 3 into and the answer would come out to 0?
I still don't know if I understand.
So when you factor something, remember like it's like x plus 2, x minus 7. Those are factors. So I'm looking for a factor like that I could fill 3 into and it would come out to 0.
-3.
So factor has a very small. So something with, so you got to say something with an x. Let's try. Let's try x plus 10. That's a factor.
Yeah.
That's a linear factor because it's to the first power.
Mm-hmm.
If I plug in 3 for x, do I get 0?
Nope.
No.
No, I get 13. So that's not it. I'm looking for what would be it. And it looks kind of like that.
Is it not x minus 3?
Yeah, x minus 3. So if you know 3, did you say x minus 3?
She said it like 2 minutes ago, and that's why I was like, oh no, it can't be that. It has to be something else.
Yeah, I thought I did.
Okay.
She
Yeah.
said that.
So would it, for -4, it'd be x plus 4?
Right. The pattern, if you know a number that's a root, this is the pattern for the factor. It's x minus a number. 3 was a root. X minus 3 is a factor. -4 is a root. X minus -4 is a factor. Okay, so once you know the factor, once you know the root, write x minus, and that's your factor. And now what I can do with that is I could multiply it out. And And if I were to graph that on the calculator, it would cross the x-axis exactly at 3 and -4. Let's check it. Let's put in x squared plus x minus 12. And if we did it right, it'll cross at 3 and -4. Perfect. Yep. And I know it's going to cross there because that's how we built it. We picked factors to make it cross at those 2 points. All right, so that's the next one we're going to look at. I'm going to give you some roots, and I want you to tell me what I could graph on the calculator that it would go through those roots. Okay. But just keep this in mind, and that'll help you. Okay, so I want a polynomial of degree 3. That's a cubic. How many? Well, when you do a quadratic, you have 2 factors. How many factors do you have when you do a cubic? Yep.
Is it 3?
3. You always have as many factors as the degree. Yeah, that's why quadratic has 2. So now you've got to give me 3 factors that I can plug each of these 3 numbers into, one at a time, and I get 0 separately for each one of them. Let's start with x minus 2. What would be a factor that I could plug that into? Yep.
X plus 2.
X plus 2. Doesn't matter what you have for any of the rest of them. If you plug in -2 right there, you're going to get 0 times anything is always going to be 0. So we got 1. What would be a factor that I could plug 1 into? And the result is 0.
X minus 1.
Yep, x minus your root. And now I need one more factor that I could plug 3 into. Yeah. Now it's just a matter of multiplying that out to get your answer. Okay, so we got x squared. What's -x plus 2x? X. And 2 times -1 is -2. Okay, that's the first 2 multiplied. Now I got to do one more. Okay. What's x times x squared? X cubed. What's x times x? X squared. And what's x times -2? -2x. And now distribute your -3. -3x squared minus 3x. And -3 times -2 gives me +6. Okay. Now we got to just combine any like terms that we can. X cubed, we don't have anything with that. Do I have any x squareds I can combine? What do we get when we combine them? -2x squared. Okay. Any x's that I can combine? Yep. How much? Yep. -5x. Anything else that's left over?
6.
+6. Okay. Let's graph that. And if we did it right, where should it cross the x-axis?
-2, 1, and 3.
It should cross at -2, 1, and 3. If it doesn't, then we made a mistake somewhere. So x cubed minus 2x squared minus 5x plus 6. So remember, we're looking for -2, 1, and 3. So there's my -2, 1, 3. Perfect. Any question on working from the roots to the factors and then to the final answer? Because the last one we're going to do is exactly this, but in reverse. I'm going to give you this.
Hold
You're going to work backwards to the factors
on. Hold on.
and then back to the roots. What's that?
That's not.
No, it's like the same thing as this, but reverse.
Forgot.
Yeah. So here's the final answer, like we just had it in the last problem. Okay, x cubed and all that stuff. Now, depending on if it's x cubed, that potentially could be a hard problem. But I'm going to give you one that something nice is going to happen. And in this one, they give you a hint to use factor by grouping. So factor by grouping means we're going to start with these two terms and factor out anything they have in common. What do the first two terms have in common? Yep, x squared. If you factor out x squared, what would that leave you with?
X plus 2.
That would leave you with x plus 2. Now, we're going to look at these last two. And we're going to see if there's anything we can factor out of those. Anybody see what you can factor out there? Yeah? 4. Let's also do a negative with it, since they both have a negative in front of them. Let's do a negative 4. And if you factor out a negative 4, what are you left with inside your parentheses?
X minus 2. Or x plus 2.
X plus 2. When you're doing factor by grouping, that's exactly what needs to happen. You have to end up with the same thing in parentheses. If you didn't, then factor by grouping is not going to work. You can check it. Negative 4x minus 8. So yeah, that's perfect. So now you factored out what they each had. Now look at this and look at this. What do each of those have in common now? Yep. They have an x plus 2. So now we're going to factor that out. If you factor x plus 2 out of this first one, what's left? Just x squared. And what if you factor x plus 2 out of the second one?
Minus 4.
Minus 4. Okay. So now, we started with the final answer. And we've worked back to getting some of our factors, and what we have here is almost what we had. Actually, it's what we have right here. We're at this step now. Now we got to get back to that step. Then we can easily get to that step. So let's see if we can get back to that. 3 separate factors. This one's going to factor again. This one can't, because it's already x to the first. Nothing else you can do with it. But how does x squared minus 4 factor? Yep.
X plus 2, x minus 2.
Right. X plus 2, x minus 2. That's a difference of 2 squares. So now you're almost back to this step. You're at this step. Now we're going to get back to that step. Set each factor equal to 0 and solve. What do you get if you set that first factor equal to 0? Negative 2. How about the second factor? Same thing. It still counts as an answer. It's a repeated answer, so you don't have to write it twice. And what about when you set the last one equal to 0? So 2. So x equals negative 2 and 2. So this answer, this is what we call a repeated root. Anytime you graph something with a repeated root, the way that it looks is it bounces off the graph at that point. It doesn't go through, it bounces. So see how this one, all 3 roots, it goes right through the axis. It doesn't bounce off the axis at all. Let's put that one in. X cubed plus 2x squared minus 4x minus 8. So negative 2 is a repeated root. It should look like it bounces off it when it hits it. Just like that. So right at negative 2, it bounced right off the axis. Any question on that? So that's finding roots from a polynomial. And then if you get one like this one that's not factorable, how can you find the roots on here if you had to do it from a graph? Yeah?
Look at where it intercepts.
Okay, and how would you calculate that exactly?
Second trace.
Second trace?
Well, you gotta put the line equal to 0 first, and the y equals.
Only if you want to do an intersect. You don't need another line if you want to do something else.
Oh, can you just do 0?
We can just do 0.
I've been doing it wrong.
So you can just do 0, and it's going to give us what we already know. 2 is a root. I didn't type in this problem, which is the one I could have. But if you get one that you can't factor, you can just type it in and do second calc 0, and you got to do it as many times as you have. Okay, so for this one, you'd only have to do 2. But you might have to do up to 3.
So are the roots the ones that either tend to go through the x-axis?
Yes. Yep. The roots or the zeros are where it crosses or touches the x-axis, your x-intercepts. So all those ideas are all connected. They all mean the same thing. Any other questions on that? All right, so that's 3.3. So tomorrow we'll look at a faster way we can do long division. Sometimes. Sometimes we have to do long division, sometimes you don't. You can do it a little bit shorter with what's called synthetic division. Okay, so those are the problems for tonight. We've got about 15 minutes or so. So we've got a little bit of time. You could work on that. Reminder too that this week we'll be doing the take-home on Wednesday because of the field trip and then the tour day, half day Friday.